This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi all, welcome to this episode of Software Engineering Radio. Our guest today is Adam Frank. Adam is SVP, Product and Marketing at Armory.io. Armory is focused on providing solutions for continuous deployment at any scale for all developers. Adam has over 2 decades of software development experience. He's focused on delivering products and strategies that help companies attain optimal business agility. Welcome to this show, Adam. It's great to have you here. Is there anything you'd like to add to your bio before we get started?
That was a fantastic introduction. Thank you for having me. I'm very excited about being here. Optimal business agility. Well, that does sound nice there at the end, huh?
Before we start, I'd like to point our guests to a few related episodes that we have done in the past. These are episode 498, James Sokol on continuous integration and delivery, episode 567, Dave Cross on GitHub Actions, and lastly, episode 338, Brent Laster on Jenkins to build server. So Adam, can you kind of help us build on episode 498 by helping our listeners recap what exactly is continuous integration, continuous delivery, continuous deployment, and what is the CD? Is it continuous delivery or continuous deployment in CI/CD?
Well, that's an ever-going debate, I would say, in these days between continuous delivery and continuous deployment. But let's start with continuous integration. First of all, that's been around for quite some time and is absolutely a practice that everybody needs in their software development. Continuous integration is really about producing that artifact, going through and having automated tests and just having an artifact that is up to the standard that you believe it should be in a really automated fashion. Continuous delivery, in a nutshell, is focused on automating the process to have a release-ready artifact. So with a manual approval in place, you can then deploy that artifact out to your runtime environments. Continuous deployment, the other CD in CI/CD, is really about automating that last step. So when developers are committing their codes, there's an artifact being created out of their continuous integration process. That artifact is being deployed out to their runtime environments without any manual approval. Now, of course, with continuous deployment, there are a whole bunch of safeguards and practices that I'm sure we'll get into. But at the end of the day, it's really about automating that deployment of that code out to the runtime environments.
So the big difference between continuous integration and continuous deployment is the approval needed?
Yeah, the difference between continuous delivery and continuous deployment is as simple as that. Like I said, it's the focusing on having a release ready and automating that release ready. So there's no manual intervention with continuous deployment. And it's a fantastic practice. We certainly encourage everybody, and it's very attainable these days, especially with the safeguards in place, like doing canary deployments and blue-green deployments and having automated checks in place and things like that. Really just orchestrating that deployment across all of your different runtime environments so you can have the confidence that the change you are making will remain safe and improve your customer's experience.
I think we'll get to that a little bit in the context of some later questions and investigations I'd like to do around differences between B2C and B2B. However,
most definitely.
At this time, just focusing on the big picture, do you think there's a big difference between implementing CI/CD for a monolith versus a microservices-based product?
Oh, great question. So the practices there are the same. The practices there are really quite similar. The differences with the microservices and the monolith are those microservices each have their own individual responsibilities. So you can make smaller changes to smaller areas of your overall experience you are delivering. With the monolith, you're typically if you're making a change to one area, it's typically updating kind of that entire area. So a lot of people with monoliths really get into the practice of continuous delivery and have that manual check in place at the end to release that release ready artifact with a checklist to just ensure an extra layer of safety. And when it comes to the microservices, that's really where people are starting to employ a lot more of the continuous deployment and automation. I mean, they have their own responsibilities, and some teams are responsible for different microservices, so they want to continue to move fast and iterate, and that all allows them to do that.
So are there any prerequisites before somebody starts implementing CI/CD?
That's a fantastic question that we get from a lot of our customers all the time. When we're talking to prospects, and when I talk to a lot of developers, they say, we really want to do continuous deployment, but we just don't have this integration test automated. Or, we've got a security scanning process that we need to run. So it's just something that we're not quite ready for. When in fact, I believe quite the opposite. You don't have to have everything automated to then go and employ continuous deployment. If you don't have an integration test automated, that's okay. If you need to do some security scanning, that's okay. That's actually great. We certainly encourage that. As part of orchestrating your deployment, you can have some checks in place. You can have the artifact deployed out to the environment. You can have the integration test run, and then you can click the approve button and have that continue on to the next environment or the next stage within your overall deployment. That's all great. We encourage people. We help you get there. You can get to the fully automated process. I don't think you can't just because you don't have one piece automated.
So that manual approval is contingent on some manual test passing. Is that what you mean?
Exactly. Yes. Yeah. If there was an integration test there, or there was some security scanning that needed to pass successfully before it continued on to production, anything of that nature. It's really about orchestrating the checks and balances that you have in place. And when that passes, then the deployment carries on. I would say the major prerequisite to doing any type of continuous delivery or continuous deployment is really having a continuous integration process in place. And that's where a lot of developers start. Obviously, getting that build automated, having that artifact ready, that's absolutely a prerequisite. We don't recommend anybody jumping straight into continuous delivery or continuous deployment if they're not actually practicing continuous integration and having that build artifact automated.
What about the actual update? Shouldn't there be a prereq of making sure that it's a zero downtime update?
Oh, so back into the microservices and the monolith. That's a great point. Zero downtime updates are absolutely a goal for a lot of organizations. You can help mitigate some of that using traffic management, service meshes, and things like that as part of your deployment process. Certainly with load balancers, blue-green deployments, kind of shifting that traffic for users. There's a lot of things that you can do there to really mitigate that zero downtime and get as close to zero downtime as possible. There are certainly some application and development practices that you would need to employ as part of your application that would live outside of some of that process, which we certainly encourage. And I think there are a lot of people practicing that today. We certainly are with our SaaS offerings, having that zero downtime. But there's a way that you can do it to really, really mitigate it using a number of techniques throughout your continuous deployment process. So it appears zero downtime, I would say.
So back to the question I had earlier, and if you had any examples, that would be great. But is the approval process or the practice of adopting or choosing between continuous deployment and continuous delivery any different for a B2C SaaS and a B2B SaaS?
We've got a number of customers that are B2B, and then we've got a number of customers that are B2C. I would say some of the largest complexities that we see with B2C are different regulations and geographical constraints. People are creating apps that are both on the web, on mobile phones. There are a lot of different processes and regulations that occur within there. So while they are practicing continuous delivery and pushing code out, something like the App Store, as an example, they would absolutely have a manual process in place to make sure that a lot of the regulations, the checks, the balances are in place before the latest version of that particular app is available on the App Store. I mean, I'll use Snapchat as an example. Snapchat is a global company. They're in over 100 countries, absolutely massive in India, and they have so many different regulations that they need to deal with. And they're deploying across thousands and thousands of Kubernetes clusters as backends. So they are both practicing continuous deployment in some areas and in different areas of the planet, just around the globe, but certainly different areas of the application. But then continuous delivery in other areas, and using their main app as an example, and going through App Store process and making sure that all the checks and balances are in place there, both from Apple and both from Snapchat. They do have manual approvals that are in place to make sure that the changes are not breaking changes and stay within the regulations and customer experience that they are expecting to deliver.
So how does one start the journey, beginning with identifying what is the best process based on my unique goal or my organization's unique goals?
Yeah, a lot of people start with that one team in the organization that is really a team that everybody looks up to. They're kind of a little bit more mature, a little bit more advanced in some of their processes. They've taken the time to really hone in their integration process. They've really taken the time to start adopting and practicing new methodologies and adopting new technologies. So what we've seen is a lot of people will take that poster child team within the organization and they'll work through the process that they need to be able to automate their deployment. And some nuances in there can be they require different security scanning. They require different constraints put in. So they've got multiple environments. They deploy to the west of North America and then the east of North America before they go out to Europe or something of that nature. They set forth that process with that team, and then it's all automated. And of course, people within the organization are looking up to that team, and that team has now increased their velocity even more, increased their reliability even more by really honing in and employing continuous deployment. And then they start to roll on the next team and the next team. Then the more teams that they roll on, the better and better they get at kind of drawing out process and adopting very similar processes. We have a very expansive customer base right now that is really in a lot of the elite category of development, doing thousands and thousands of deployments per day. And something that we noticed when we looked at all of the different pipelines that all of these different customers were setting up was that when it comes down to it, people were really doing almost the same 4 or 5 things. So when you start to realize that, you can start to roll teams on much faster and you can start to have process ready to go for them. And there's a lot of companies out there that they've been able to come in and use a single pipeline, a single process for a lot of this, despite different areas of their application or what it may be. And that, of course, has certainly accelerated things and made the platform engineers' life a little bit easier as they draw out process.
You mentioned 4 or 5 things. Can you elaborate?
Yeah, I mean, integration tests are one. Everybody's doing a level of integration testing. Security scanning. The vast majority of people are doing some type of security scanning or signing, for that matter. Everybody's got at least 3 environments, from seed stage companies that we talk to all the way up to the largest top Fortune 100, top Fortune 50 companies. Everybody has at least 3 stages: dev, stage, and production. So they need to be able to deploy to dev, do something, deploy to staging, do something, and then deploy to production. And in that order, those are the constraints that they would want put in. And that's kind of the, one of the largest scenarios that we see out there is, everybody's got 3. And then it grows from there, 3 to 5 to 10 to hundreds, around the globe, different environments, different regions and things of that nature. And then you start getting into a little bit more of the advanced use cases. You start getting into a little bit more of the blue-greens or the canaries, and then automating canary analysis. So when it comes down to it, everybody has that goal of increasing their reliability and moving quickly without breaking things. So they want to start by deploying to those 3 environments, running tests like integration, making sure that the code is secure, there are no vulnerabilities and things of that nature, and then start getting into 5% of that traffic and 10% and 25% up to 50 and analyzing that in an automated fashion so they know that the change that is being rolled out is safe and they can have that confidence to continue pushing multiple changes and multiple updates per day.
Thanks, Adam. So I wanted to explore a little bit the manual approval before delivering to production and the potential cascading effect of that. So if you have multiple services that have a dependency, meaning if my service A has a dependency on B and B has a dependency on C, and if I have a manual approval, at what level should I do that? At the service level? And if I do it at more of a product level, which includes all the services, what are the challenges I would have? I'm thinking just constructing environments to do full end-to-end testing with all the latest code in place. Does my question make sense?
It does, absolutely. We have a good amount of customers that do have tightly coupled services and need to make sure that those are all updated in any type of sequential fashion or updated simultaneously. And that includes rollbacks. So if there is a rollback needed, those tightly coupled services also need to roll back. Some of the difficulties that we've seen there with some of the manual approvals that people had in place beforehand were really making sure that the sequence, the dependencies were known and things were done in the correct order. I mean, I can take you back 15 years before if there's even proper continuous delivery put in place. I used to have to update this application that we had when I was on call. And there were 9 different services, and you had to update service 1, service 2, service 3, service 4, all the way through service 9. And each one had their own manual approval. Each one had their own manual testing. Each one had their own manual everything. And when we were confident that one was good, we went on and updated the next one. And then as soon as we found out we were on service 4 or service 5 and the update didn't work, then we had to go back and roll everything back because there was no fixing it and rolling it forward at that point in time. So there were a lot of difficulties having that manual approval in place like that. And that's, again, where some continuous deployment can actually help. There are solutions out there, ours included, that enables you to automatically update tightly coupled services and roll back tightly coupled services as needed, understanding those dependencies.
So if somebody did have such tight coupling, then continuous deployment is certainly a challenge. However, let's say people, especially in a B2C SaaS environment, have a much better structure where they are able to do continuous deployment. What does this mean to the customer experience? So the consuming company will now be exposed to changes almost continuously. What does it mean for them to be able to test as well as look at any new features that are coming with the changes being made available?
So I want to step back on that just for a second, because I want to be very clear that the best way to change a user experience is by leveraging feature flags. You don't want to have a feature a quarter completed or half completed or anything like that out there for users to stumble upon and think that it doesn't work or it doesn't work as it's supposed to. And, perhaps support tickets and bugs and things like that raised when it's not a complete full feature. So continuous deployment is still deploying that code out there, having it ready. But when it comes to actually changing the user experience significantly like that, we certainly recommend using feature flags. Now, smaller changes that may not be changing the customer experience to that dramatic effect, that, again, you can control using traffic shaping. So you can do it to 5% of the traffic, 10% of the traffic, 25% of the traffic, and make sure that everything is working as it is intended to. And the users aren't going to necessarily notice that level of change. But like I said, when it's a bigger feature or let's say a UI refresh, you're completely changing where buttons used to be. You're going from a top level nav to a left-hand nav. You would certainly want to change that type of experience with something like feature flags. So the code is continuously deployed out there, but the actual change to the user is done through something like feature flagging. If not, you're going to have a left-hand nav and a top-hand nav at the same time. And, we work in a very agile fashion, and we're going to iterate on things. So having a top-level nav and a left-hand nav with, one module in the top and one module in the left, that's going to be a very clunky user experience. And they're absolutely going to think that your application's broken in that case. So again, that's where something like feature flagging comes into the SDLC and works really, really well.
So episode 498 did delve into some detail on the feature flag and just the complexity maybe in deciding when you start on something, is it going to need a feature flag? What's your experience on that?
I think a lot of the times when we're designing a new feature, a new experience, from the vision of that and that North Star goal that we have for it, we can understand if there's going to be feature flags needed or at what level feature flags will be needed. There's a lot of underlying changes that you can make to a particular feature or implementing a new feature that may not interrupt, may not be there for the user to experience. But a lot of the times that I've seen developers and the team, the product development team that is creating this, has a really good sense of when the user is going to be able to start viewing this, start using this. So they know when something should be feature flagged. I mean, have it as part of your planning. Make it part of the discussion. Make it part of the design phases. Like, at what point are we going to feature flag this? We're going to feature flag it right from the beginning. Are there changes that we can make and then feature flag? It is a practice that really should happen at the onset.
So as maybe let's end this section of just drilling into testing. So on the developer side and on the integration side, what are the different kinds of tests you would expect to have in the pipeline, and environments? So do we talk in terms of a unit test setup, which is automated in a dev environment, and then a pre-production environment? What are the different kinds of environments do you recommend, and what are the different levels of testing automation do you recommend?
Yeah, definitely unit tests. Absolutely. Unit tests in the development environment. Typically, integration tests absolutely happen in a full-fledged staging environment. Security scanning and security tests oftentimes happen in another isolated environment, one that is before your production environment, alongside the staging environment we see quite often as well. And then, of course, there are certain smoke tests and things like that that run when the deployment happens out to production. And again, with something like canary analysis, even some of those end-to-end tests and testing some of the user experience, baselining that metric or those metrics that are communicating back to you what the customer is experiencing, what the latency looks like, what the saturation looks like of your particular application, and understanding that baseline to move forward with your deployment, to increase that traffic, to move it from customers in the West to customers in the East, things of that nature.
And then what about testing on the consumer side of the B2B application? Do I also need to have automated tests every time the SaaS provider is updating and deploying to production? Is that recommended?
On the consumer side of things, no. I mean, I can't think of a single service or application that I use as a consumer that I have any type of tests running. I think we really have to trust. And part of that reliability and stability and customer experience that's being delivered to us is allowing us to have that level of trust. And it's an incredibly competitive market and competitive day that we live in. I can move to another service. I can move to another application very, very quickly and still achieve what I need to achieve, whatever that may be. Think of streaming services as an example. How many streaming services are out there now? You start to have a bad experience with your streaming provider, you can move to another streaming service very, very quickly. So we have to trust. And if that trust is broken, that company is going to pay, not us. We're going to move. We're going to go continue to live our life and experience it.
On the B2B side, though, it is more sticky. So does your answer change for the B2B app?
Depending on what the level is, absolutely. A lot of B2B apps, there will be some level of integration with other B2B apps. And those two companies may or may not have a relationship with one another. This may be something that was created by these companies together jointly. There's an integration there. And you don't necessarily need to test that if they are working together and ensuring that the quality is there. If it's something that you created yourself to stitch two applications together, to stitch two processes together, I would absolutely recommend testing it. If there's no relationship between the two companies and it was a third party that created some level of integration or something like that, I'd absolutely want to test it. And the larger the enterprise, the larger that application is, and the more business critical it is, the more we would absolutely recommend, testing there as well.
And hence creating an automated test suite.
Yeah, most definitely.
Okay, let's switch now and spend some time on the developer experience and the tooling, maybe just starting with the evolution of this tooling for CI/CD.
Yeah, I think developer experience is something that has certainly come to the forefront. And if we look back at kind of the inception of DevOps, bringing development operations together back in 2007, 2008, there was the whole mantra about creating a culture of you build it and you own it at any cost. There are a lot of complexities with that, and a lot of things that have to be known in order to fully own it and operate it. And I think that's really where we've seen the evolution and the new role and responsibility of site reliability engineers and, as of late, platform engineers. Site reliability engineers and platform engineers should still very much work in a DevOps and agile manner. Don't get me wrong. DevOps is still very much alive, but now platform engineering has kind of been that focus a lot more on the developer experience to really empower the developer, to enable that developer to own it and build it by providing a platform that increases and improves that developer experience. And if you look at all the different nuances of the software development lifecycle, creating that platform that enables the developer to deploy their code fast at a high quality, increasing reliability and assuring their customer experience. You increase your developer experience, you are definitely going to increase your customer experience. So I think it's something that's really come to light over the last couple of years as businesses try and stay more and more competitive, move faster. So there's a whole suite of processes and tools that kind of underlie that platform to increase and improve the developer experience. And continuous deployment is certainly at the center of that.
Can you cover the tooling and the evolution, maybe at a high level?
Yeah, for sure. I mean, we just kind of talked about the DevOps mentality that was there of build it, own it. And, first continuous integration tools and automating a lot of that build. There's a huge market for test tools and quality assurance. Security, as of, more and more as of late, has started to shift left and become into observability. Came around in about 2015. It was no longer just the ability to monitor from the outside things that are happening, but really being able to observe the internal of an application from telemetry it's creating. That means there's a massive market for observability now. Hot on the heels of continuous integration was continuous delivery. And then even more automation came in place with continuous deployment. And DevOps has really enabled people to continue to move quickly. But I think more so now that developer experience is at the forefront and platform engineering is starting to have a focused responsibility on enabling and empowering those developers. You see them with responsibilities of providing testing frameworks, providing continuous integration tools, providing continuous delivery and deployment tools, providing the observability suite and framework, whether that's set between the developer and the site reliability engineer. They are certainly looking to improve both experiences and first and foremost the developer, so that code is of high quality and being deployed quickly.
So earlier in the podcast, you mentioned customer of yours that has hundreds or maybe thousands of deployments a day. What kind of challenges does that create?
As soon as you said that, another customer came to mind that has over 125,000 deployments per month. They are a technology company that's been around for many, many years. And I think some of the challenges that I can think of that they have really seen, We sat down and chatted with them in a seed stage company at the exact same table. And it was so interesting to hear the complexities that they talked about and the complexities that the seed stage company talked about, and just, them kind of smile back and forth at each other from time to time. Like they're both crazy, living in a world that neither of them even remember or can fathom. I think some of the challenges that this very large company has experienced is they've got 8 different languages that they need to support across hundreds of applications. They've got underlying infrastructure that is using multiple cloud services, from serverless to container services to container services that they've built within their own data centers. They are a company that's around the globe. So they've got multiple regions, again, different regulations in different in different countries. So they have got an immense amount of complexity depending on what application updates they're deploying and where they're deploying it to. So I think part of it is really establishing that culture, and you're going to really be able to establish and help that culture by empowering your developers. The more you empower those developers, the more they're going to get on board with the overall culture.
So for these deployments, since there's such a huge volume, how do the developers track if deployment has to be rolled back? What are the metrics they would typically use to determine that, and I assume do that automatically?
Yeah, the most basic ones are really looking at some of the underlying infrastructure metrics. Those ones are easy, but every application is going to have its own set of metrics. And it's really up to the application development team that understands what those metrics are and the experience that they're delivering. I mean, you can look at things like golden signals, looking at saturation, looking at latency, looking at response times and things of that nature that are certainly going to help you establish, does this need to be rolled back? The latency was 1 second before this change, and now it's 3 seconds. That could be detrimental to the application, or it could still be okay. That's really up to the development team and understanding the experience that they are delivering. So being able to look at those metrics and understand when things need to roll back or can continue forward, and then going even further and doing that in an automated fashion and having statistical analysis and machine learning do that for you. I mean, that's the ultimate prize. And that's very achievable in today's world. That is very achievable with our solutions and practicing the continuous deployment out there.
So how has generative AI, if at all, changed this? You mentioned machine learning.
Yeah, I think generative AI, in terms of the software development lifecycle, I think the area that we're seeing the most focus in right now is code generation. Part of that code generation can be configuration generation as well. So producing different sets of YAML that may be needed. And when we live in the world that we live in, Kubernetes really introduced us to declarative, and being able to produce some declarative configuration has been a pretty easy process for generative AI. When it comes to doing machine learning on metric data and things like that, that's been around for a number of years now, before this big generative AI bang. That's been a great process that has worked for a number of customers, a number of people, a number of developers that we have great relationships with and help every single day. But I think the generative AI, the big boom in it right now is really the code generation. Armory is a global company. And I think one of the biggest uses that we have it for right now as a global company, English is not the first language for a lot of the company. And being able to have a common language that everybody speaks within the code using comments and things like that to help other developers understand what the thought process was and what this code is supposed to do has been really helpful. It's been great using generative AI to help write a lot of our comments and things like that. Fast prototyping, using generative AI to produce some levels of code for fast prototyping has also been really, really great for us. But in terms of deployment at this stage, I think we're still very early on. Although I did write an article about some prototyping and practicing that we did a couple of months ago. So I think there is most definitely a future beyond declarative that is generative when it comes to continuous deployment.
So maybe let's switch to Armory and unique aspects of Armory's solution then. I read about continuous deployment as a service. What is that? Can you elaborate?
Sure. Armory started out in 2015, 2016. And at that time, Netflix was one of the leading development organizations in the world. And they had developed internally a project called Spinnaker. And Spinnaker quickly became the de facto continuous delivery, continuous deployment project out there on the market. So Armory adopted commercializing Spinnaker. And one of the biggest advantages that Armory has had over other companies is being able to work with elite development teams that are kind of at the forefront of adopting early stage technologies like Kubernetes, early stage practices like continuous deployment, and at very large scales. I mean, like we talked about, hundreds of thousands of deployments per month across several different environments around the globe. We've been able to learn an immense amount from our customer base. And continuous deployment as a service is really the evolution of that. So what we knew we needed to do was create a simpler offering that was full-fledged in power. So declarative came along with Kubernetes. So CD as a service is really a declarative continuous deployment process that orchestrates the deployment of that artifact from your artifact repo across all of your environments. It allows you to hook in security scanning, integration testing. Any different process that you have fits directly into your SDLC. The traffic shaping that we've been talking about, the blue, green, the canary, all that great stuff. It's all in there. It's very, very powerful. It is, as you can guess by the name, as a service. So it also has auth and RBAC and things like that all built into it. So it's a full package ready to go for any development team. Any platform engineering team that is looking to increase and improve their developer experience and spend more of their time focused on their competitive advantage can leverage CD as a service as their CD control plane.
So then you take over the challenge of scaling. If somebody is doing hundreds of thousands of deployments, I assume you have to make sure that your platform or your service scales up to that.
Oh, most definitely. Most definitely. And part of that evolution, we looked at other open source projects and we saw a lot of difficulties with those in terms of scale when it does come to some of these larger organizations. And that's why we developed it from the ground up. And it's been so much fun developing it from the ground up and working with some of the best technology companies in the world and working with a lot of seed companies at the same time that don't have the funding or time to employ people to build out a CD process, a CD solution based on open source projects and other things like that. And don't get me wrong, we are huge advocates of open source. We're still very much contributing back to several open source projects that are out there. Big fans of the CNCF and everything that's happened there as well. So I think there's a big, bright future for CD as a service, the community in general, and people who are getting started with continuous deployment.
So is there a difference in recommendation to teams that are getting started depending on how many different products that they want to integrate and build CI/CD pipelines for versus some team that's just getting started and has a very small, maybe a couple of services that they will be testing?
The more tools you have, the more it's going to take to manage them. So people, and the more they're going to cost, whether it's an open source project and you need to hire people, there's some costs there, ramp up time, knowledge, all that kind of good stuff, or it's some type of subscription service. So the more you have, the more it is going to cost you. So we absolutely see, ourselves included, tool rationalization and consolidation and all of that good stuff. So I think whether you have a couple of services or whether you have 100 services, I think you should always try and keep your platform as tight as possible so you can manage it easier. You can help keep your costs down. And there are some fantastic tools out there. OpenCost is a great open source project. Cloud Zero is an example that can help you really manage your costs at the same time. Not just your infrastructure, but translating those to your business costs and everything that you have in and around your platform and what you are serving out.
So you did talk a little bit in the context of generative AI on what's in the future, but do you want to elaborate and talk about some other stuff that you're looking at Armory?
One of the big things that we are working on right now that we're incredibly excited about comes from the learnings that we've had with a lot of these customers. Kubernetes has taken the world by storm, but every single customer that we have and every single prospect that we've talked to has Kubernetes and something else. And Kubernetes is also complex. So a lot of people don't have the time and energy to invest in it. So they move to simpler container services like ECS, Amazon's ECS as an example. So there's still very much a large world out there that requires deploying to more than just Kubernetes. So we are actually working right now, releasing it very soon, on our next target, which is Lambda, and building that out so people can build additional targets that they need as Armory continues to build out more and more targets. So people can deploy from a single platform to more than just Kubernetes. They can deploy to Kubernetes, they can deploy to Lambda, they can deploy to ECS, and so on and so forth. That's something that we're working on in the near term right now that we are very, very excited about. And then, of course, security supply chain is a big one right now. And that's a story that we haven't really told yet. Full capability is there, but it's a story we haven't really told yet. And making sure that the code that you are deploying to development, the code that you have written, is signed, and that is indeed the code that is making it out to production, is another one of those shift left security things that's very, very important. And it's just a story that we haven't quite told yet. Further down the road, yeah, absolutely. The generative AI stuff is very, very exciting. We have absolutely started to play with it to the point where you've got brownfields first. Everybody's got some level of infrastructure in place. So simply providing the account information, the credentials to that infrastructure, to any tooling, and letting the generative AI connect them. And then simply using text to say, this is going to deploy, or deploy this using blue-green, or even letting the generative AI figure out whether blue-green or canary is the proper strategy there. It's really exciting stuff to see what we're doing. Brownfield's different. There's a lot more complexities there when there is no infrastructure or nothing in place. I think that'll take a little bit longer to figure out, but needless to say, it's still very much an area that is being explored. Greenfield, sorry, I think I said brownfield there twice, but I meant greenfield in the second one there.
Got it. Adam, do you think there's any key topic that we missed talking about today that you'd like to cover?
No, I don't think so. I've had a ton of fun today. We've covered a lot of ground when it comes to continuous deployment. I think this is going to be a fantastic episode for all the listeners out there, and certainly excited to come back and do it again and continue talking about developer experience, perhaps, or platform engineering. Two incredibly exciting topics again.
Adam, how can people contact you?
People can reach me anytime at adam.frank, that's adam.frank, at armory.io, armory.io.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.